The third group of equivalence factor that we want to deal with is the uniform series sinking fund and compound amount factor. So basically that is A over F or F over A. Uniform amount A, future value F. And we realize with the cash flow diagram as shown in here, you have a uniform amount A over period of time N, and at the end, the equivalent F equal to how much, or vice versa. So this apply in the real problem, like you go to work and you have a retirement saving. Every year we have a annual uniform saving, let's say 10,000 per year. You start at 23 years old and retire somewhere 67 years old for tens of years, 40 years, 45 years of retirement. How much I have or you have when you retire F, and that you determine whether you will become a millionaire when you retire or billionaire, etc. So that basically talk about the saving and the retirement. All of that can apply in these scenarios. So with that here, again, I just write the equation instead of elaborate with the induction for to drive the equation itself, something we did in the first group of equivalence equation. So with that here, we can have, if given F, then phi A, if my target is retire at $10 million in my pocket, how much I have to save per year now? With the I%, then you have given F phi A, so it will be I. How can we find out? So basically, just a relationship between the first two. You have A equal to P, I 1 plus I power N, and 1 plus I power N minus 1. And P, go to the first group that we learned, 1 plus I power negative N times F. So we just plug that in with that two equation that become simple equation. I cancel out the 1 plus I power N, so you have that it equal to equal to 1 plus I power N minus 1, and that is the equation, or you use the table, then the reference, then it will be 2A given F, I% and years. Similarly, if it given A phi F, so F equal to A, and just flip 1 plus I power N minus 1 over I, or equal to, if use table A, 2F given A, I% N. Similarly, for the note here, very important in P and A. P must always be located one period prior to the first A. This one, as you can see, the last A and F at the same location. So the note here, also very important, that if future value F, future value F occur in the same period as the last A. The last A. Very important. Last A at year end, F at year end. So keep that in mind. So make a box in here when you apply. And let's apply that to equation to problem 3. How much money would Brandon have in his investment account after 8 years if he deposited 1,000 per year for 8 years at 14% per year starting 1 year from now? Again, always start with the cash flow diagram. And in this case, years again. For 8 years, so it will be 0, 1, 2, 3, 4, 5, 6, 7, 8. He deposits, so it go out his pocket 8 years starting 1 year from now. So now it's 0. 1 year from now it's 1, 2, 3, 4, 5, 6, 7, 8. A deposit uniform amount. A equal 1,000 per year. How much money Brandon have in investment account after 8 years? So that it will be after 8 years. So what he have is the question asked. So given A5F, you can be able to use equation. So we have F equal to A with the ratio 1 plus I power n minus 1 over I, and in this case I 14%, so I equal 14% per year. So it will be, you have 1.14 power 8 minus 1 divided by I 0.14. So that equal to what number? 13,232.76. That is the answer. We apply the equation. Now use table in the reference, or and now you will justify which one I should use after this. Should I use equation or should I use table in these problems? So use table, and let's go to of course the with the looking for 14%. So go to 14%. You have 10, 12, 18. So the reference we don't have. So how can we do? We just interpolate. Okay, so the 12%, and F over 8 for 8 years. So it will be, as you can see that number here, 12.229, right? 2997 for F over 8 at 8 years. And then at 80%, F over 8 at 8 years, it will be 15.3270. So that with that tool in the table, we can interpolate. So that use the table, and in this case multiple table. And by now you say, wow, I have to interpolate, and that doesn't justify to do. We apply the equation above and can get information immediately. So in this case, it makes sense to use equation instead of table. 12.2997. And if we have F over A for 18%, 8 in that table, it will be 15.3270. So from that we can interpolate, and you can apply the equation of interpolate, and I give that to you to try yourself instead of me to go over this, and we do interpolation in the remember, show you in the square foot cost estimate, that equation. So 14%, that equation we want to interpolate here, it equal to 13. And don't pick approximate. This one it matters, so it have to really interpolate if you use the table. So from that one, we can have the equation here. If we use table, F equal to A times factor F over A, 14%, 8, and it equal to A 1,000 time 13.3088, and the answer it will be 13,308.80. So you see a little more off compared to the equation you apply. And now, by now, you see with that equation, if you have the table with the same interest, it makes sense to use the table. In this case, the interest 14%, we don't have that table in the reference. It makes sense to apply the equation directly. So it's your call, but that is the rule of thumb to use, whether we use table or use equation. If you have time, you use both and check whether you got correct answer.